As we look at the second part of section 11.1b, the first part we talked about products. Now we're going to talk about quotients. And one of our basic ideas is our rules is we cannot have a fraction inside a radical, and then as an answer we can't have a radical in the denominator. So both of these are unacceptable solutions that we have up here in our original problem. So what I'd like to do is teach you how to manipulate our problems in such a way so our answers will not have a fraction inside the radical or a radical in the denominator. The first trick that we can learn is we are allowed to take a fraction that's in a radical and split it up into two parts and then take the square root of each part. So 144 over 9 I split into two radicals. Now I take the square root of the top and the square root of the bottom, and I say 12 over 3. Does that reduce? It sure does, and so my answer is 4. On my second one, I'm going to break that top up into 25x cubed and the bottom into the square root of y squared. Now I'm going to break the top into two square roots as we learned in the first lesson. 25x squared root x over the square root of y squared. Now we're going to take the square root of the top. The square root of 25x squared is 5x, and that root x is left over. The square root of y squared is just what's inside, or just y. So there's our answer. Our third one on this problem, we're going to break up the 72 on the top and break up the 49 to the bottom. Can you think of what goes into 72 that's a perfect square? Well, 36 does, so 36 times 2 is a perfect square. And the 49x to the 6th is already a perfect square. So let's simplify our problem. The square root of 36 is 6, so we have 6 root 2 on the top. And the square root of 49x to the 6th is 7x to the cut the 6 in half, x cubed. So there's our answer. Now, each one of these problems had a perfect square in the denominator. These problems are simple because we don't have to rationalize the denominator. But what I'd like to show you next is what happens, or what do we do, when our denominator is not a perfect square. Well, we have two options. The first option is sometimes you'll be able to actually cancel the radical first and then simplify. For example, 54 and 2. Do you observe that they're both even numbers and the 54 divides by 2 evenly into 27? If you did, then you can finish the problem by breaking the 27 down into 9 and 3, which gives you an answer of 3 root 3. Let's look at the next one. 8 divides by 2 into 4. X cubed divided by x to the first is x squared. Remember, you subtract exponents when you're doing these kinds of problems. Well, now we take the square root of 4x squared. Well, that's 2x. Does it work on this third one? I hope so. 18 divided by 9 is 2. And x to the 5th divided by x to the 9th. Since the bigger one is in the denominator, they're going to end up in the denominator. 9 minus 5 is x to the 4th. Both of these we can go further with. The x square root of 2 stays on the top because it is not a perfect square. But x to the 4th is a perfect square, and that becomes x squared on the bottom. So each of these three second cases, we were able to simplify the fraction first and then take the square root.